Okay, what's going on, folks? Today we're going to be learning about refracting light. Um, this is something that I believe most of you probably have some experience with. Um, so here we've got a guy. He's sitting in a pool, and you can see this is where he's actually sitting. This is where his head is, and you would expect his body to be directly below him. But because light travels at different speeds through different materials, we can see that it looks like his body's way over here. That's where this image of his body is, even though it should seem like it should be directly below him. So this isn't photoshopped or anything. This is an actual photograph that someone took. Um, And it's strange because his body's way over here, but you'd expect it to be over here. So why is that? Maybe an example of this that you're have seen more commonly is if you have ever had a glass of water with a straw in it. You'll probably notice that the straw looks like it should be here, but in fact it's over here. So again, this is due to refraction. So that's what we're going to be learning about today. So let's first define a few terms. Medium, that's a material that light can travel through. Some common mediums include air, water, gas, and other fluids. Light travels at different speeds through different mediums. And so here we're going to do an example where light is traveling through one medium, air, and then it reaches another medium, water, and we'll kind of show what happens to the light when that happens. So remember that before light hits a boundary, we call that an incident ray. So a wave of light before it enters a new medium. That's the definition of an incident ray. And so then a refracted ray is going to be a wave of light after it enters a new medium. So here we have a ray of light. It was in the air, and now it's in the water. So refracted ray, a wave of light that enters a new medium. Normal, remember that's just that line that we draw where the incident ray meets the reflected or the refracted ray. Normal is the perpendicular line that crosses the boundary point at the spot where the incident ray and the refracted ray meet. Perpendicular, what does that word mean? Well, it means it comes at a 90-degree angle. So the line has to go through where the incident ray meets the refracted ray, and it's got to be at a 90-degree angle to the boundary. Incident angle, so that's going to be the angle in between the normal and the incident ray. So the incident angle is the angle between the normal and the incident ray. The refracted angle, that's going to be the angle between the normal and the refracted ray. So the angle between the normal and the refracted ray. And what we're going to be learning about in this lab is the index of refraction. So that's the measure of how much a medium bends light. Denser mediums usually have a higher index of refraction. So more dense materials will bend light more, usually. Less dense materials will bend light less, usually.